If you watched our last video, you saw that we wrote the equation of a rational function when we were given a picture, the graph of that rational function. This will be a very similar process when I don't have the picture, but instead I have this written description. And I've gone ahead and divided this up into parts A, B, and C, because this is how I would approach any of these problems. If your problem wasn't divided this way, you certainly could divide it this way yourself. The first thing I'm going to find are the x-intercepts. These will determine what the numerator, the top of my rational function, is going to be. So my x-intercepts or my zeros, this time it says one of them occurs at 1. So that tells me that as a numerator, I'm going to have a factor of x minus 1 that would get me 1 as a possible x-intercept. And then I've got another x-intercept at -2, but this one just touches the x-axis, or what we've been saying in class, it bounces off the x-axis. So what that indicates to me is not only do I have a factor of x plus 2, I want to use the opposite to get this to work out correctly, but it tells me I have that raised to an even power. So I'm going to just stick with 2, although 4th power could work or 8th power could work. Any even power would make the graph bounce. So there's my numerator that comes from the x-intercepts. Let's move along then and talk about the denominator. The denominator is going to, the denominator is going to be determined by where my vertical asymptotes are located. So I've got one at 4. So similarly to what we did with the x-intercepts, I know that one of my denominator factors must be x minus 4. Once again, I use the opposite. And then x plus 1. And if I wanted to multiply this all out, I could, although I don't want to. So those two things will determine where my vertical asymptotes are. I never want to have 0 in the bottom of a graph, so that gives me my my vertical asymptotes, sorry. Final piece of this puzzle then is any fine-tuning we might have to do, and that's going to be determined by the horizontal asymptote. This time we're told that we don't have a horizontal asymptote, there isn't one. And according to that chart we made the other day, and that's my note at the bottom here, if we don't have a horizontal asymptote, we have to make sure that the degree of the denominator is less than the degree of the numerator. In other words, there needs to be more degree, sort of is what I say, more degree in the top of the fraction than there is in the bottom. So let's see if we have that or if there needs to be any fine-tuning. The degree of the numerator this time is 3. If I were to multiply it all out, I'd have x to the 3rd power. The degree of the denominator is 2, so once again, we're okay. We don't need to adjust anything. There is more degree in the top. Top-heavy is kind of what I called these. So that means there would be no x-intercept. There would be no horizontal asymptote. All I'll do to make this into a function is just go ahead and throw an f of x equals in front, and there's going to be my rational function. If you want to check it, just go ahead and graph this. Be careful because you may need to use like double sets of parentheses, so I'll throw brackets around here, if you're graphing these on your calculator. And then you can graph it and confirm that all these things are true. You can look for an x-intercept of -1. You could look to make sure the graph bounces at -2. You could check your table even to see if those points are there, and check your table to see if you get error messages when x is 4 and x is -1. Very easy to check these, but here once again is my equation of the rational function.